Greetings, everybody. Excuse me. Today we're going to talk about dividing polynomials of the form that you see here, which is a cubed plus b cubed or a cubed minus b cubed over a plus b or a minus b. Now you'll notice here that these are the sum and difference of two perfect cubes. Now in other places you might find methods for factoring the sum and difference of two cubes, and actually the objective of this video is to show you how to factor the sum and difference of perfect cubes using polynomial division. So what we're going to do here is we're going to take a look at a little problem. Okay, a simple one. Notice the numerator is the difference of two perfect cubes. And you'll notice the denominator, each term of the denominator is the cube root of its perspective or its respective term in the numerator. Okay, so knowing polynomial division is actually a quick way to factor these, to learn how to factor. So we're just going to review the polynomial division process of this, and then we will actually factor it. And I'll show you how to use that technique to determine factors in a few moments. Okay, so we're going to set up some polynomial division, x minus 3. Oops, sorry about that. A little correction here. Okay, x minus 3 divided by x, or divided into x cubed minus 27. Now remember, because there are terms missing in this polynomial, it's always handy to put placeholders in for them just using a zero coefficient, like so. So you want to make sure you have all four terms of this polynomial present so that you can do the proper long division for it. Okay, so what we're going to do then is we're going to divide, and we're going to do x goes into x cubed x squared times. Notice I'm lining up like terms, and that a lot of times helps students make sure they place things appropriately here in the bottom as you continue your division. Okay, so we do x cubed times x squared times x is x cubed. All right. And then we do x squared times negative 3 is minus 3x squared. Okay? And then we, of course, subtract this. All right, so we do x cubed minus x cubed, it just goes away, and then that leaves us with 3x squared. And then we bring down the next couple of components, just like you would normally do in any long division problem. Okay, then you ask yourself, what would you multiply x by to get 3x squared? Or how many times does x go into 3x squared? Well, that is a positive 3x times. Okay, so then we follow the pattern again. We do 3x times x gives me 3x squared. Okay, and then 3x times negative 3 gives me negative 9x. Okay, and then of course we subtract, and those will cancel out, and this becomes 9x, and then we bring down the 27 to continue the division. Now finally you ask yourself, how many times does x go into 9x, or divide into 9x, and that is positive 9x times. I mean, not positive 9 times, not 9x times. Forgive me there. All right. So we say 9. So 9 into times x is 9x. You know, follow the pattern again. Then negative 27. And then, of course, subtract again. And then these just cancel out. And you're left with no remainder here. So you get a 0 remainder. And so this actually divides to equal the quotient, which is just x squared plus 3x plus 9. Okay, and if you do these correctly, there should be no remainder for this style of question, for these perfect cube questions that we're doing today. All right, so these two statements are equivalent, that when you have this rational function, it is equivalent to this polynomial. All right, so let's look at a second one, a little more complex. All right, this one's only slightly more difficult just because of the size of the numbers in the numerator, and you just have to be careful in your multiplication. So we do 2x. We set up our polynomial division. So we say 2x plus 5 divided into 8x cubed plus, don't forget your placeholders again, squared, 0x plus 1, 2, 5. Okay? So now we do our division. We do 2 goes into 8x cubed, 4x squared times. So then we do our multiplication. 4x squared times 2x is 8x cubed. Then 4x squared times this is positive 20x squared. And of course we subtract. We subtract, and these two terms subtract out, and this becomes negative 20x squared, and then we bring down the remaining terms to continue our long division. All right, so now we ask ourselves, 2 goes into negative 20x squared minus 10x times. So we do negative 10x times this, just repeating the process again, gives us our negative 20x squared. And then negative 10x times 5 is negative 50x. And of course, we subtract again. Okay, those subtract out. And here we have a 50x. Oh, let me fix that. Okay, so we have 50x. Now remember, this becomes 50 because this negative sign changes that sign, this sign, when we do the subtraction. So the negative becomes a positive. And then we bring down the 125 because we haven't used it yet. Now we ask ourselves, what would we multiply 2 by to get 50x, or how many times does 2x go into 50x? Well, that's 25 times. So we have a plus 25 up here. And so we do our multiplication again. 25 times 2x is 50x. Then 25 times 5 is 125. And finally we subtract again, and both terms subtract out, so we get a 0 remainder. And what that means is that this is the quotient of our subtraction. Okay, so our answer to this division is 4x squared minus 10x plus 25. Okay. Now I want you to notice a little pattern here. If you'll take a look at our answer, our quotient, you'll notice that this number, or this term, is always this number squared. So notice 4x squared is the square of 2x. You'll notice the last number is this guy squared. And then the middle term is a little different because the middle term is the product of these guys. You'll notice the product of 2x and 5 is 10x, but with an opposite sign. And that is a common pattern to this type of division.